These are your first notes on Chapter P. These are your prerequisites. That means it's something that you should know already. And if you don't know some of the stuff that's in this video, you really should learn it as soon as you possibly can. So the first thing in this chapter is the definition of real numbers, the types of real numbers and their properties. Pretty much all of the numbers you've been dealing with up to now are considered real numbers. Let's start here in the middle with the natural numbers. The natural numbers are your counting numbers, like 1, 2, 3. They're the numbers that you count with. So whole numbers include all the natural numbers, but whole numbers start with 0. So for whole numbers you also include 0. And then you have integers. Integers include whole numbers, which includes natural numbers. The integers are the positive and negative whole numbers. So you include the 0 and the 1, 2, 3, 4, 5, but you also include the negative numbers like -1, -2, -3, like that. Rational numbers are numbers that can be written as a fraction. So these will be fractions, or they will be terminating or repeating decimal numbers. So something like 1/4, that would be a rational number. You could have -2.3. This is a decimal number that terminates, it stops. But you could also have something like 0.6 repeating. You know, if you have a portion of that decimal part that repeats over and over, that's called a repeating decimal, and those are also called rational numbers. Numbers that are irrational are not included in any of these types of numbers. Irrational numbers are numbers like pi and e. Or you could have something that goes on and on forever, like 2.613982006, da 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 da. It just goes on and on forever and it never repeats. Those are called irrational numbers. The real numbers include all of these types of numbers. Now when we get to section P.7, we're going to be talking about some imaginary numbers. That will be something even further out here. Imaginary numbers are numbers that aren't real. But we don't have to worry about that right now. Let's just worry about the real numbers. So real numbers include rational numbers and irrational numbers. The rational numbers include integers, and the integers include whole numbers, and the whole numbers include natural numbers. So I hope this helps define for you the real numbers and their properties. Now let's talk about sets. Now in this page, we were talking about sets of numbers, the set of natural numbers, the set of whole numbers, things like that. Well, sometimes you're going to see these symbols. These symbols stand for things in reference to sets. So like this one means is an element of. My handwriting is horrible on this thing, by the way. So this little E looking symbol means is an element of. So if you look back here, you could say that 2 is an element of the natural numbers. And if you wanted to write that out, you would say something like this. 2 is an element of the set of natural numbers, which is this crazy looking N that has 2 bars in the middle. Something like that. 2 is an element of the natural numbers. This one means is a subset of. Some people read this as is contained in. So looking back at this page again, you could say that the natural numbers is a subset of the whole numbers. That's just one way you could look at that one. This symbol here means is a subset of or is the same set. You know how you learned before, if you have this with the little equal to, it means less than or equal to. That's kind of what this little line means, is a subset of or is equal to. So now we have some properties of real numbers. You have the distributive property, which we will be talking about a lot. That's where you take what's on the outside of a parentheses and multiply it by everything on the inside of the parentheses. You distribute that factor. The commutative property of addition and the commutative property of multiplication, it just means that you can switch the order that you add or multiply things. So here you see the x plus 6 is before the 5. Here it's still the same way, however, the x and the 6 are in a different order. So you can switch the order you add or subtract things and it doesn't really change the answer. Then you have the associative property of addition and the associative property of multiplication. That means you can group addition and multiplication differently and it'll still work. Here you see the x plus y are grouped together, but it's in the order x, y, 3. X, y, 3 still the same order, however, on the right hand side, the y plus 3 is grouped together. Here the same thing, you have 6xy, 6xy, but here the 6x is grouped and here the xy is grouped. So for addition and multiplication, you can group them differently, or you can order them differently, and you still get the same answer. The additive identity is just 0. It means what can you add to something so you get the something back. So 0 is your additive identity. The additive inverse means what can you add to something so that your answer will be 0. So if I ask you what can you add to b to get 0, you would say negative b. So what do you add to 2 to get 0? The additive inverse of 2 is negative 2. The multiplicative identity is 1. What do you multiply by something so that you get the something back? So the multiplicative identity is always 1. Let's put this in here. The additive identity is 0. The multiplicative identity is 1. The multiplicative inverse means what can you multiply by something so that your answer is 1. So I want to know what can I multiply by 2 so that I get 1. I would have to multiply it by 1/2. So the multiplicative inverse of 2 is 1/2. How about absolute value? The real definition of absolute value is the distance of a number from 0. So if I said, what is the absolute value, that's what these little bars mean, what is the absolute value of 4, that just means how far is 4 from 0? Well, it is 4 units from 0. Well, what if I ask you, how far is negative 4 from 0? Well, negative 4 is also 1, 2, 3, 4 units from 0. So the shortcut has always been whatever is inside the absolute value, you make it positive. But the real definition is the distance of a number from 0. So what is the distance between negative 2 and 8? From negative 2 to 8, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 10 units. That's the distance between them. Well, to calculate that, you would say the absolute value of 8 minus negative 2. You could also say the absolute value of negative 2 minus 8. Either of those would give you a distance of 10. So now let's talk about exponents. In exponents, remember the big number is called the base, and the little number is called the exponent. Okay? The little number, the exponent, tells you how many times to multiply the base times itself. So 2 to the 5th would be 2 times itself 5 times. And if you were to multiply that out, you would get something like 32. So now we have order of operations. I'm sure most of you have heard this before. Please excuse my dear Aunt Sally. And I know that you know P stands for parentheses, E is exponents, M is multiplication, D is division, A is addition, and S is subtraction. I put these two on the same line, because multiplication and division are equal. You do the one you come to first when reading left to right. Addition and subtraction are equal. You do the one you come to first when reading left to right. So whenever you have a fraction like this, you treat the entire numerator as one problem, the entire denominator as one problem, and at the very end of the problem you either divide, which is what this bar means, this fraction bar, it means divide, or you could just reduce the fraction. So looking at the numerator, I see an exponent. I do see parentheses, however, inside the parentheses there's nothing to do. So let's take care of exponents. Negative 3 squared is going to give us 9. We're just going to do this one little step at a time. Look at the denominator. We do have stuff in parentheses, and things can be done inside those parentheses. Negative 3 minus 2 is going to be negative 5. 5 minus a negative 1 is the same thing as 5 plus 1, which is 6. Now back to the numerator. We have multiplication here. We have to take care of that first. So negative 4 times 3 is a positive 12. So we get 9 plus 12 plus 9. And in the denominator, all we have is multiplication. We get negative 30. Finally, in the numerator, we get 9 plus 12 plus 9. If you add all of that up, you're going to end up with 30. That's over a negative 30. Well, if you divide this, 30 divided by negative 30, you get negative 1. So this entire problem simplifies into negative 1. Now we have some laws of exponents. These are just things that you need to remember. If you have x to the 1, you just get the base back. Anything to the 0 power is 1. This one is really important. X to the negative 1, this is the reciprocal. It means flip it over. You get 1 over x. If you have the same bases that you're multiplying, you just add their exponents. If you have the same bases that you're dividing, you subtract the exponents. If you have a power raised to a power, you multiply the exponents. Here we're multiplying two bases, but we're raising that whole thing to this power. So you could raise each thing inside to that power. That's what this one looks like. Here you're dividing two things. You could just raise both of those to that power. That's this one. This is kind of that reciprocal again. X to the negative n could also mean 1 over x to the n. Like up here, x to the negative 1 is equal to 1 over x to the 1. Well, you don't really need the 1. That's why they didn't put it there. We're going to be talking about this one a little bit later. So let's work a few examples. In your notes, we're actually going to work these two a little bit later in a different section. So let's not do those right now. Look at this first problem. We have absolute value, and we have something multiplied and something raised to a power. But when you have absolute value, you kind of have to treat it like parentheses. So let's do these exponents first. So we have 2 times 3 minus 5 squared is 25. Then we're going to multiply before we subtract. So we have 6 minus 25. 6 minus 25 is negative 19. The absolute value of negative 19 is 19. And then 19 minus 6 is 13. Okay, this problem over here, you're just multiplying like bases. Negative 2 times negative 3 is 6. X to the 4th times x is going to be x to the 5th. And then y squared times y to the 5th is going to be y to the 7th. Remember, when you're multiplying like bases, you add their exponents.